Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is sequence and the series, we are going to learn another segment of it, that is AP series. So let's begin. After completing the very lesson today, my dear student will be able to find the sum of terms in our AP series. This is what I hope you'll be able to do after completing the very lesson today. So as usual in your favorite segment of the lesson, Mars is found today, my dear student. I want to explain that there are a group of prime numbers called Republican prime. I will explain what those prime numbers called Republican prime after completing my lesson today, so don't go away. To begin the lesson, my dear student, let me first explain what is a series. A series is nothing but a sequence of numbers, but what happened to that very sequence, instead the comma between the terms, what you now see there is either plus sign or the minus sign. That is the addition or the subtraction sign is what will now separate the terms in that very sequence. Then we call it a series. Examples, you have number 1, 5 plus 7 plus 9 plus 11 plus 13 plus it continues like that. You can see what is separating the terms 5 and 7, 7 and 9, 9 and 11 is addition sign, and then it is called a series. Other examples, you have 7 plus 4 plus 1 minus 2 minus 5 minus 8. Another example, you have 1 plus 2 plus 4 plus 8 plus 16 plus that it continues. Another example, you have 800 minus 200 plus 100 minus 50 plus 25 minus, it continues like that. You can see in these 4 examples, what separated the terms in that very progression is nothing but either a plus sign or a minus sign. That makes it a series. So let us move and concentrate on AP series. So let us just move. So what we now learn next is how to find the sum of the very first n terms if it were AP series. So the sum Sn, that is the total if you now add all the terms that there from first one up to term number n. So that the sum is now denoted by Sn. Of the very first n terms, if it is AP, is given by this simple formula. This is the formula Sn, that is the sum, equals to r over 2 multiplied by open bracket. Inside the bracket, you have 2a plus another bracket open inside the very first one. The inner bracket contains n minus 1, and that inner bracket multiplied by d. This is the formula we now used to find the sum of the very first n terms if it is an AP series. We still have another formula. It says Sn equals to r over 2 multiplied by the bracket. Inside the bracket is a plus the tn, where a is the very first term of the AP, d is the common difference, and n is the number of the terms, and the last tn is the last term. So these are the variables contained in this very true formula. You can either use the very first one or the second one, depending on what you have in the question. If in the very question you have the last term and you have the very first term, and you know the number of terms from first up to that last term, so you can use this second formula. Is much easier. But if it is only first term common difference and the number of terms you want to find their sum is what you have in the question, so you can use the very first formula. So we are going to take examples how we can make use of each of this, the different formula, and find the sum of the very first n terms of the series. So let's just move, take examples. Example number 1, we asked to find the sum of the very first 20 terms of the AP series. This is the series 9 plus 12 plus 15 plus 18 plus, it continues like that. So solution to this very problem, what we do first is to write down the formula for finding sum of this series. So the formula says Sn equals to r over 2 multiplied by, and there is a bracket. Inside the bracket, you have 2a plus another bracket open inside is n minus 1 multiplied by d. So what we now do is to find your a, your n, and your d from this very series. So a is 9, as you can see, the very first term of the sequence. Next is d. Remember, d, we now take any two successive terms and subtract. So in this case, I will take a 12 and 9. 9 is first term, while 12 is the second term. So I'm going to subtract 9 from 12. That will give me the common difference. And subtracting 9 from 12 gives answer 3. So 3 is your common difference. And next is to find the n. N is now 20 because we asked to find the sum of the very first 20 terms. So I have all the 3 variables in this very formula. So I'm just going to substitute. So I'm now going to have s to 20. I have replaced the n by 20. Look at it. I'm interested in some of the very first 20 terms. So substituting the right hand side, you now have 20 over 2 multiplied by bracket open. Inside the bracket is 2 times a, where you have 2 times 9a replaced by 9 plus the bracket open 20 minus 1, that is n minus 1 multiplied by d. D is 3 here. So we continue. So we now simplify this very problem. So I can divide 20 by 2, do this multiplication, do this subtraction inside the bracket. Let me just move ahead. So I'm going to have 10. 20 over 2 gives you 10. 2 times 9 gives you this 18. And 20 minus 1 gives you this very 19. So I continue. So 19 times this 3, the number 3 outside this very bracket. So what I'm going to do next is to perform this very multiplication before the addition. So I'm going to have 10 multiplied by bracket open. Inside the bracket is 18, which I copied, plus 19 times 3. That what gives you 57. So I'm going to add 18 and 57 together, then later multiplied by 10. So I'm going to have 10 multiplied by 75. 75 is the result of 18 plus 57. This multiplication 10 by 75 gives answer 750. So the sum of this very first 20 terms of this very series is now going to be 750. Let's just move and take another example. Example number 2, we asked to find the sum of the series. That is, find the sum of this very series. I have 19 plus 1 minus 17 plus dash, but this is the last term of that very series, minus 1 to 5. So there are other terms in between, which we don't know how many, but we are to add them all from this very first term up to the last term, including the missing terms that we don't know. So solution to this very problem, what we do first is to write down the formula. I have the last term, so I'm going to write the second formula there, which says S R equals to R over 2 multiplied by the bracket. Inside the bracket is A plus Tn, where Tn is the last term. So I'm going to use the test to extract those details there. So I'm going to have my first term 19. Look at it here. 19 is your first term. The common difference D, which we now take 2 successive terms and subtract. So I'm going to take 1 and 19. 1 is the second term, 19 is the first term. So I'm going to subtract the first term from the second term. That gives me 1 minus 19, and this result will now be minus 18. This is your common difference. So next is your last term, Tn, is given as minus 125. Look at it. But we would like to have n, that is the number of terms from this first to this last term. How many terms are there? We must find that number of terms. So in that case, n is question mark. But the last term is now minus 125. The position of this very term, this last term, it is position, tells me how many terms are there put together. So I'll need to find this n. So I'm going to use the formula for term at any position in an AP. That is our second lesson in this main topic. So remember, the formula says Tn equals to A plus bracket open. Inside the bracket is n minus 1 multiplied by d. This is the formula we used to find the term at any position if it were AP. What we are interested basically here is to find the position of this very last term. That tells me how many terms are there all together. So substituting Tn by this minus 125 and substituting other variables, I'm going to have minus 125 equals to 19, your first term, plus bracket open inside is n minus 1 multiplied by your d, which is minus 18. Look at it here. So simplifying this will enable you to get n, and that n will now be the number of terms. Then you can now go back to this main formula and substitute n, a, and t, and so that you can now find the sum of those terms of that AP. So let me just move. So simplifying this, we now have minus 125 equals to 19. Opening this bracket by multiplying by minus 18. So n times minus 18 gives you minus 18n, and minus 18 multiplied by minus 1 gives you positive 18. So we now collect like terms. There gives me 18n shifted to the left, and minus 125 shifted to the right, so that I have constant numbers by the right. So that gives me 19, which I copied. 18 also, which I copied, but minus 125 shifted to the right gives answer positive 125. And I now shifted minus 18n to the left. That gives me positive 18n. So I continue. So collecting these numbers correctly gives answer 162. That is 19 plus 18 plus 125. So next we now do divide both sides by this coefficient of n to get n. There gives me n equals to 9. That is 162 divided by 18 gives you 9. So which means that this minus 125 is term number 9. So if I'm to find the sum of those two terms all together, which means I'm finding some of the very first 9 terms. So I'll now go back and substitute S9, n is now 9. Will now be equals to n over 2, that is 9 over 2, multiplied by bracket open inside the bracket is a, which is 19, plus your tn, which is minus 125, look at it here. So I continue. Plus minus will now change it to minus. So you're now going to have 9 over 2 multiplied by 19 minus 125 is what gives you 106. So you now divide this 106 by 2 because you are multiplying it by 9 over 2. So 2 in this 106, that gives answer minus 53. So 9 times minus 53 simply gives you result minus 477. So this is the sum of the very first 9 terms of this very series. That is sum of these terms all together from 19 to this minus 1 to 5, including the missing term. Let's just take one more example. Example number 3, we asked to find the sum of the first 100 multiples of 3. So solution to this very problem. Remember, multiples of 3 refers to those numbers we have as a result of multiplication by 3. Let us see those numbers. Those numbers that are multiples of 3 will now form our AP series, starting with the very first term 3, the next term 6, the next term 9, and the next term 12. The next will be 15 and so on. These are terms on this series because these are exactly multiples of 3, starting from the very first one. And we asked to find it there are some. That's why we now said it is a series. So we now write down the formula. The formula for sum of that AP series is given by SR equals to over 2 multiplied by bracket open. Inside the bracket you have 2a plus another bracket open inside the very first one. The second bracket contains n minus 1 and that second bracket multiplied by d. So now determine our a, our d, and our n here. So our a, the very first term is 3. Look at it here. Look at it in the sequence in the series. I beg your pardon. The next is the common difference, where we take any two successive terms and subtract. Subtracting 3 from 6 gives you 3. So if you have multiples of 3, the common difference is nothing but 3, because addition of 3 all the time gives you the next multiple. So your d is 3. Next is n. N we asked to find the sum of the very first 100 terms. So n is equals to 100. So we now substitute in this very formula. So we now have S100, that is sum of the first 100 terms, equals to, I'll now substitute N, A, and D by the right. So I'm going to have 100 divided by 2, multiplied by bracket open inside the bracket is 2 times 3. I have replaced A by 3, plus bracket open inside is N minus 1, where N now replaced by 100 minus 1, then the bracket times 3. I'll now simplify this. So 100 divided by 2 gives you 50. 2 times 3 gives you 6. 100 minus 1 gives this answer 99. Then multiplied by 3. So I'm going to do this multiplication first. So 99 multiplied by 3 gives the result 297. I copied my 6. I copied my 50. So I'm going to do this addition, then the result multiplied by 50. If that addition is done correctly, you have 303. That is 6 plus 297. 50 multiplied by 330 gives you the sum as 15,150. This is the sum of the very first 100 terms of multiples of 3. With this, I have come to the end of this very lesson, my dear student. I hope you find it resourceful. And let me just move quickly to the last segment, Maths is fun, and explain what group of prime numbers are called Republican prime. So Republican prime are prime numbers such that the right half of that very number is prime and the other left part is not. Let's just take an example. Example is 6,661. This is a Republican prime because if I now divide this number into two halves, 66 and 61, 66 and 61, this is the right part and this is the left part. So it says the right part if it is a prime number again, then this number 6,661, which is prime, then this number is called Republican prime. Other examples of Republican prime, you have 113, 1019, 1031. In case of three numbers, you now split, or you now take last digit and the very first digit, you now leave one digit at the middle. If now compare the right digit there, if it is prime, then that number is a Republican prime, just like in case of this 113. So we see more of these things in mathematics in our subsequent lessons.